Hello students, today we'll do exercise 5.1, question number 6. Find all the points of discontinuity of f where f is defined by f of x is equal to 2x plus 3 when x is less than or equal to 2, 2x minus 3 if x is greater than 2. Now, when will you say a function is continuous? A function is continuous at a point if first thing is the function should be defined at a. That means f of a exists. Second, limit value exists. Then limit value should also be equal to the function value. Only then we say the function is continuous at a point. Less than or equal to 2 it is defined as 2x plus 3 and greater than 2 it is 2x minus 3. So we are going to check if the function is discontinuous at this point. It is enough you check the discontinuity at this point. So we are going to check. First we are going to find f of 2. At 2 we are going to check. At x is equal to 2. At x is equal to 2, the function is at 2. The function is 2x plus 3. At 2, the function is 2x plus 3. So substitute x is equal to 2. Substitute x is equal to 2. You will get 2 into 2, 4 plus 3. 2 into 2, 4 plus 3, that is equal to 7. So the functional value exists. F of 2 exists. So now the first condition is okay. Now we have to check the limit. So when will you say the limit exists? When the left limit is equal to the right limit. Isn't it? The left hand limit should be equal to the right hand limit. Only then we say limit at x tends to a of f of x exists. So let us first find the left hand limit. So left of 2, limit x tends to 2 minus the left of 2. So less than 2, the function is 2x plus 3. So you just write the function here. And less than 2, how do you find the left hand limit? You have to substitute x is equal to, you have to replace x as 2 minus h. Then when x tends to 2, when x approaches 2, h will be 0. H tends to 0. So h tends to 0. Replace x by 2 minus h plus 3. So when you put h is equal to 0, it will become 2 into 2, 4 plus 3, 7. So the left hand limit is equal to 7. Now you have to find the right hand limit. So right hand limit means limit x tends to 2 plus of f of x. That is, now right of 2, right side of 2, the function is given as 2x minus 3. So it is 2x minus 3. So right side, how do you write? You put x as 2 plus h. H is a very small number. So it's a small increment from 2, right of 2. So when x approaches 2, what happens to h? When x approaches 2, h will tend to 0. We put 2 here, h will tend to 0. So put that h tends to 0. 2 into x is 2 plus h minus 3. So when you put h as 0, it will become 4 minus 3, that is equal to 1. So you can see that the left limit is not equal to the right limit. That means the limit doesn't exist. The second condition is not satisfied. Limit doesn't exist. If the limit doesn't exist at a particular point, that means the function is not continuous at that point. That means the function is discontinuous at x is equal to 2. So the point of discontinuity of this function is at 2. Left of 2 and right of 2, it is a continuous function because left of 2 we can see a linear function and right of 2 is also a linear function. At 2 there is a break. Now we'll go to the seventh sum. F of x is equal to modulus of x plus 3 if x is less than or equal to minus 3 minus 2x if x lies between minus 3 and plus 3, 6x plus 2 if x is greater than or equal to 3. So you know that modulus definition, modulus of x is equal to x if x is greater than or equal to 0 and is equal to minus x when x is less than 0. So this modulus function we have learned already. So we are going to replace this modulus of x as minus x because x is less than or equal to minus 3. You know that x less than 0 itself, 0 is somewhere here. So less than 0, the function is minus x. So minus 3 is less than 0. So I am writing here minus x. The other functions as it is. So only modulus of x, you are replacing it by minus x because the definition is minus x when x is less than 0. So x is less than minus 3. That means x is less than 0. Then at minus 3 and plus 3 also we have to check. Minus 3 the function is defined less than minus 3, minus 3 to plus 3 and greater than 3. So we have to check if the function is discontinuous at minus 3 and plus 3. So let us first check at minus 3. First let us find the functional value, that is f of x is equal to minus 3. Can you see the equal to sign here? Equal to minus 3, the function is minus x plus 3. So we are writing it minus x plus 3. Now put x is minus 3, you are finding the value of the function. So put minus 3, so minus of x is minus 3. So plus 3 is equal to 6. The function exists. F of minus 3 exists. Now we have to find the left limit. We have to check whether the limit value exists. So we have to check the left hand limit, left of minus 3. So we are going to check whether the left hand limit and right hand limit are equal. So let us first find the left hand limit. So left of minus 3, the function is minus x plus 3. So I am writing it as minus x plus 3. Now how do you find the left limit? You have to put x as minus 3 minus h. Minus 3 minus h. So replace x by minus 3 minus h. It's very easy to write minus 3 minus h. Then put h tends to, then limit h tends to 0. Always whenever x approaches, x comes closer and closer to minus 3, the small increment will disappear. So h will tend to 0. So h tends to 0. So minus of minus 3 minus h plus 3. Put h as 0, you will get plus 3 plus there is equal to 6. Now let us find the right limit at minus 3. So right limit, how do you write? And the right limit, right side, right of minus 3. See, minus 3 to plus 3. So after minus 3, the function is minus 2x. Up to minus 3, it is this, minus x plus 3. So right of minus 3, it is minus 2x. So we have to write minus 2x. Now you have to replace x by minus 3 plus h. Minus 3 plus h and h tends to 0. So when you put h tend to 0, it will become plus 6. So left hand limit is equal to right hand limit, therefore the limit exists. And also the limit value at minus 3 is equal to the function value, the value of the function, that is f of minus 3 is also equal to 6. The limits, left hand limit and right hand limit, both are equal to 6. Therefore the function is continuous at x is equal to minus 3. That means minus 3 is not a point of discontinuity. Now we have to check 3. So 3 also we have to check. The function at 3 also we have to check, because it is from minus 3 then plus 3 is given like that. So we have to check for 3. Now we have to find first f of 3. What is f of 3? At 3, the function is 6x plus 2. At 3 equal to 3, the function is 6x plus 2. So f of 3 is 6 into 3 plus 2. 18 plus 2 is equal to 20. F of 3 exists. Now we have to see the right of 3 and the left of 3. So right side of 3, what is the function? And right side of 3, the function is 6x plus 2. And left of 3, the function is minus 2x. Okay. So right of including 3. Okay. Sorry. So my 3 minus is left of 3, it is minus 2x. So minus 2x. Now left of 3, how do you find? You have to replace x by 3 minus h. So minus 2 into 3 minus h. Put h is 0, you will get minus 6. So the left side limit is tending to minus 6. Now let us see the right hand limit. The right hand limit is limit x tends to 3 plus f of x. So right hand side, the function is 6x plus 2. Now we have to replace x by 3 plus h. So right side limit you are finding. So 3 plus h tend to 0. So it will become 18 here plus 2, 20. So we can see that left limit is not equal to the right limit. That means the limit doesn't exist. If the limit doesn't exist, the function is not continuous. There is a break at the point 3. So the function is discontinuous at x is equal to 3. So the point of discontinuity of this function is at 3. Before 3 and after 3, the function is continuous. Next question. F of x is equal to modulus of x by x if x is not equal to 0, equal to 0 if x is equal to 0. This is called as the Signum function. So modulus of x is x when x is greater than 0. Isn't it? Suppose your x is 5. Modulus of 5 is 5. 5 by 5 is 1. So when it is greater than 0, you get 1. Everywhere you get 1. When it is less than 0, suppose x is minus 5. So modulus of minus 5 is plus 5 divided by minus 5. Isn't it? So when x is negative, the numerator is positive and the denominator x is minus 5. So that will give you 5 by minus 5 is minus 1. So all the values the left side, it will be minus 1 and the right side of 0 will be 1. And at 0 the function is defined as 0. At 0 it is 0. Okay. So it is from this. It is from at 0 it is 0. After 0 only it is 1. Similarly at 0 here 0. Left of 0 it is minus 1. Right of 0 it is. So at 0 it is 0. Right of 0 it is 1. And left of 0 the function is minus 1. So less than 0 the function is minus 1. At 0 it is 0 and 1. Right of 0 it is 1. So we have to check whether the function is continuous or not at the point 0. So let us see at 0. At 0 if you check, f of 0 is 0. Now left of 0 it is given as minus 1. There is no variable here to substitute. It is a constant function. So it is minus 1. So left of 0 it is minus 1. And right of 0 again a constant, it is 1. So left limit is not equal to the right limit. That means the limit doesn't exist. Therefore the function is not continuous at 0. So the point of discontinuity is at 0. At 0 the function is not continuous. After that it is a constant function. Here also left side it is a constant function. So the point of discontinuity is x is equal to 0. Now we move on to the ninth sum. F of x is equal to x by modulus of x. It is similar to that sum. So when x is less than 0, if you put x less than minus 3, what happens? Minus 3 by modulus of minus 3. That will give you minus 1. So left side of 0 is minus 1 and right side of 0 they have given it as minus 1. Equal to 0 is also the function is given as minus 1. So here this is the, take it as this is the origin. So left of at 0 also it is minus 1, left of 0 also minus 1, right of 0 is also minus 1. So it is a continuous function. So anyway we have to prove it. At 0 f of 0 is minus 1 because it is given. Left of 0 it is minus 1, the constant. Right of 0 minus 1. That means left hand limit is equal to right hand limit. So the function is continuous. It is continuous everywhere because at 0 if there is no break, that means the function is continuous everywhere. So at 0 only we have to check at 0 whether the function is continuous or not. If it is continuous, that means the function is continuous everywhere. So the function is continuous at x is equal to 0. There is no points of discontinuity. It's continuous everywhere. Now question number 10. F of x is equal to x plus 1, x greater than or equal to 1, and x square plus 1 if x less than 1. So two different functions at 1. So at 1 it is given as x plus 1, left of 1 the function is different, and right of 1 it is a linear function, left of 1 it is a polynomial. So at 1 we have to check whether the function is continuous or not. So at 1, first let us find the function value, the value of the function. So at 1 x plus 1, the function is at 1 x plus 1. So substitute x is 1, so you get 2. The value of the function is 2. Now we have to find the left limit. So left of 1 the function is x square plus 1 is a polynomial function, x square plus 1. So you can find, how do you find left of 1? You have to replace x by 1 minus h. So it is 1 minus h the whole square. So your x is 1 minus h. So when x tends to 1, h tends to 0. So when you substitute h is 0, it will become 1 and here 1. So 1 plus 1, 2. Similarly, the right hand limit x tends to 1 plus of the function. Now right of 1 it is given as x plus 1, right side. So how do you find the right side limit? You have to substitute x as 1 plus h. So 1 plus h plus 1. Substitute h is 0, it will become 2. So we can see the limit exists because the right hand limit is equal to the left hand limit, and also it is equal to the value of the function. F of 1 is equal to 2. The limits are also equal. Therefore at the point 1 there is no discontinuity. Okay, we have to check only at the point 1 because left of 1 it's a polynomial, right of 1 it is a linear function, it is continuous. So at 1 also there is no discontinuity. That means the function is continuous everywhere. That is, x is equal to 1 is not a point of discontinuity. Thank you.